Let's solve linear inequalities. Now, just like solving a linear equation, you can do the addition property of equality, which is that you can add whatever you want as long as you do it to both of the sides of the equation. We're going to solve these inequalities. We're going to check our solutions, and we're going to give the solution in set. So we're going to give the solution set in both interval and graph forms. So let's go for it. If I wanted to get x by itself, what would I do? I would add 5. I would end up with x is greater than 6. That is my solution set. To graph this, I would do a simple number line with a 6 on it. If I'm greater than 6, it means my arrow is going to the right. Because I'm not equal to, I'm going to do a round bracket. My interval notation would just be 6 to infinity. If I wanted to check the solution, I would pick something like 7. Is 7 minus 5 greater than 1? Is 2 greater than 1? Yep. So this is my solution. All right, try this one. So for this one, I'm going to minus 3 from each side. I get x is less than or equal to negative 4. I would do a quick number line with a negative 4 on it. Less is to the left. If you draw your x on the left always, or if you put your x on the left always, whatever way your sign is pointing is which way your arrow points, just FYI. And then because I'm equal to, I could do a square bracket. My interval notation would be negative infinity up to negative 4 with a square bracket. If I was to check this, I would pick something less than or equal to negative 4. So let's pick negative 5. Is negative 5 plus 3 less than or equal to negative 1? Negative 2 is less than or equal to negative 1. I'm good. Cool. So the addition property of equality held true. I can just add or subtract to both sides and I get my solution. Well, what about the multiplication property? Let's start with a true inequality. Let's start with negative 2 is less than 5. If I multiply both sides by 8, does the inequality hold? Well, 8 times negative 2 less than 8 times 5. I get negative 16 is less than 40. Yeah, it's all good. Okay, so far the multiplication property has held true. What if I do the same thing, but I multiply both sides by negative 8? I would get negative 8 times negative 2. Is that less than negative 8 times 40? Oh, sorry, that's the answer, times 5. Negative 8 times negative 2 is positive 16. Is that less than negative 40? No. So the multiplication property fell apart. So there's a rule. Anytime you multiply or divide by a negative number, you have to reverse the direction of the inequality symbol. So if you start with negative 2 is less than 5, if I'm going to multiply that by negative 8, you have to flip the inequality sign to keep the inequality, right? To keep it true. So now I would have 16 is greater than negative 40, which is now true. So again, there's a rule. The only thing that's different than solving a linear equation is that if you multiply, which includes division as well, both sides by a negative number, you have to flip the inequality sign. So now I have 4 questions here, and the question will be, do I or don't I? So I have 2x is less than or equal to negative 4. To get x by itself, I have to divide by 2. What I do to one side, I do to the other. Do I flip the sign? Am I multiplying or dividing by a negative? No. So if I do this, I get x is less than or equal to negative 2. If I was to check this, now we're not just graphing and interval notation here, we're just checking. I would check a value like negative 3. So is 2 times negative 3 less than or equal to negative 4? Negative 6 is less than or equal to negative 4. I'm good. I didn't need to flip the sign. But what about the next one? What if, to get x by itself, I have to divide by negative 2? Because I'm dividing by a negative number, I have to flip the inequality sign. I would end up with x is greater than or equal to 2. To check this, we're going to pick something like 3. Negative 2 times 3, is that less than or equal to negative 4? So you're checking into the original equation with nothing flipped. Is negative 6 less than or equal to negative 4? Yes. So because I flipped my inequality sign, it gave me the correct solutions. What about the next one? To get x by itself, what's happening here? Well, it's multiplying by negative half, or I could think of this as x divided by negative 2. To get the x by itself, I'm going to multiply both sides by negative 2. Should I flip the sign? Well, I'm changing pen color, so yes. I'm going to flip it. I'm multiplying by a negative number. I end up with x is less than or equal to 8. If I hadn't flipped it, I would get x is greater than or equal to 8. Let's check that. So let's check something less than or equal to 8. Let's check 6. Negative a half times 6, is that greater than or equal to negative 4? Well, negative a half times 6 is the same as 6 divided by negative 2, which is negative 3. Negative 3 is greater than or equal to negative 4. It checked out because I flipped the inequality sign. Whereas if I have a question like this, I have to solve for x. The only thing in the way of getting x by itself is this 2. The opposite of dividing by 2 is multiplying by 2. What I do to one side, I do to the other. I'd be left with x is less than or equal to negative 8. So if I check something like negative 10, is negative 10 divided by 2 less than or equal to negative 4? Well, negative 5 is less than or equal to negative 4. So I'm good. So I didn't need to flip the sign. Now, something I didn't point out is I made all of these equal to a negative number. Didn't make a difference. It's what you're multiplying or dividing by to get x by itself. Only if the coefficient on x is negative do I need to flip the sign. So this one and this one, not the ones that had a positive coefficient on x. All right, so now that we've looked at that, now we can just solve inequalities. So if I gave you something like 4x minus 3 is less than 5, what would I do first? Well, I would add 3. What I do to one side, I do to the other. I end up with 4x is less than 8. To get x by itself, I have to get rid of this 4. This 4 is multiplying with the x, so to get rid of it, I'm going to divide by x. What I do to one side, I'm going to do to the other. I end up with x is less than 2. Nothing weird. Didn't need to flip my signs. If I want to give the solution set in both interval and graph forms, I'm going to start with a graph. I'm going to put a 2 somewhere on this number line. X is all real numbers less than 2, so that's to the left. And because it's not equal to, I'm going to use a round bracket. For my interval notation, I'm going to say that it's going from negative infinity up to 2, round bracket. All right, what about this next one? Well, this next one I just want to talk about for a second, because this next one could involve a flipping of a sign, or it could not involve flipping of a sign. Remember in chapter 1 when I was trying to train you, maybe you didn't notice, but I was trying, right? To always write it where you have your x's with a positive coefficient. It's because I knew this was coming. If you always put your x's on the side that will give you a positive coefficient, you're never going to have to flip your inequality sign. So for example, if I solve this question by minusing 3x, I end up with negative 5 is greater than or equal to 2x plus 3. I'm going to minus 3 from each side. I get negative 8 is greater than or equal to 2x. I'm going to divide both sides by 2, and I end up with negative 4 is greater than or equal to x, or x is less than or equal to negative 4, which is a better way of answering it. I didn't have to flip anything, right? I mean, I did flop my x to the other side, but I kept the sign in the correct order with that, right? If I had solved this and I was someone who's like, x's belong on the left, I'm never going to put them on the right. That's cool, right? Let's minus 5x from each side. We end up with negative 2x minus 5 is greater than or equal to 3. I'm going to add 5 to each side. I end up with negative 2x is greater than or equal to 8. Then I'm going to divide both sides by negative 2. Now, because I'm dividing by a negative, I have to switch my sign. That's going to leave me with x is less than or equal to -4, I get the same answer, right? So if you're someone who's always going to put your x on the side that gives it a positive coefficient, don't worry about ever switching your sign. But, you know, sometimes it's not feasible and sometimes you end up with a negative coefficient, and that's okay too. You just have to flop the sign. To give this answer in a graph form, we're going to put on a 4, a -4. I'm less than or equal to -4, so square bracket with an arrow going to the left. Where's the arrow going? Down to -infinity, up to 4 with a square bracket. Awesome. Last question. So I threw this question on just so that you can't be complacent. Be like, I'm never going to have to switch my inequality sign. What if the question looks like this? I mean, technically, I could do this, that I wouldn't have to switch my inequality sign. But it's really a lot easier if you look at this question and be like, oh, I should get rid of this -5 first, right? It's trapping everything else. This is in a bracket. So the -5 is dividing. So I'm going to multiply both sides by -5. And I would end up with 3x minus 2. Now, because I multiplied by a negative, I have to switch my sign, and I would end up with a -30. Then I would add 2 to each side. I end up with 3x is greater than -28. Now I'm going to divide by +3, so I don't have to switch my sign. And I end up with x is greater than, oh, what's 28 divided by 3? That's not a nice answer. Dang, fraction. This was a new question I added just because there was people were getting to their homework and like, I can't do these questions. I'm like, oh, I'll put one in. So hopefully I haven't made a mistake. And so for this one, it's all right. It's a fraction, not a big deal, especially because I just get to put it on a number line. I'm just going to put -28/3. I can't simplify it. There's nothing that goes into both -28 and 3. So x is greater than, which is a round bracket opening to the right, up to +infinity. To answer this, in interval notation, I'm going to put that -28/3, and it's going to go up to +infinity. And if you're going to check this, you'd have to check something greater than -28/3. You could check something like 0, right? So if I put in a 0, I get +2/5 on the left, and then I have 6 on the right, and 2/5 is less. If you plug in -28/3, it's not going to make this equality true or inequality true because you're not allowed to be equal to 6. But the way this works is that if I put in -28/3, that's what will give me equal to 6. So if you are checking that value, even though it won't make your inequality true, you could plug in 3 times -28/3, which would just be -28. Minus 2 is -30. And then -30 divided by -5 is 6. So that's just a way of checking that your boundary number is correct, even though it won't make the, I'm doing air quotes, but you can't see them, inequality correct. Awesome. So go practice a bunch of those, and then we'll come back and look at, identities and contradictions.